So, you want to start learning about object-oriented programming in Python. Well, then this is the correct place for you. I'm going to teach you everything I know, from how classes differ from objects, how to make your very own custom initializers, what the self keyword means, how you can make methods and variables that apply to each individual object and class, and how you can use inheritance to better clean up your code. So if you're ready, let's get started. So first, let's talk about why you would want to use object-oriented programming in the first place. Code can get messy as a project is to grow, and since this is going to happen, we can use object-oriented programming to stick certain methods and variables within classes to make a better logical flow. This will A, reduce repeated code usage, and make it simpler for you to understand in the future. Now, Python supports object-oriented programming, but don't feel the need to force it. If something just is not going to be object-oriented, it doesn't have to be. You don't need every function to be within a class, just the ones that make sense to be. So, we're going to focus on primarily a practical understanding and not exactly theory. I'm not going to give you all the buzzwords, I'm just going to get you what you need to know to get started. So now that you understand a little more about object-oriented programming, let's talk about classes versus objects. This is a class, which is defined with the class keyword. This class can then be used to create a variety of objects, and an object is just like a version of that has properties that can change. For example, if we have a variable called a penguin, let's do that all lowercase. A penguin, which is a type of animal, so we can call it an animal and just call this like this to make a new object. And then we also have a rhino. Both of these are animals, but they're different. So for example, since we have this property called feet, we can say the rhino dot feet is equal to 4, because a rhino doesn't have 2 feet, it has 4. So now, if we do a little bit of printing here, and we print out our penguin's feet count, and we print out our rhino's feet count, then we can see exactly what happens. So let's run this code. And as you can see, the penguin has 2 feet, the rhino has 4 feet. And as you can see, these are both animals, but they have different properties. Objects can have different properties that can change. Meanwhile, the class is more like the blueprint to say what properties they can have to begin with. So now that you understand the difference between classes and objects, let's talk about some cool things we can do within a class that affect objects. So let's talk about methods. Methods are just functions within a class that all of its objects can use. So let's just say we have a variable called stomp count, and every time we call the stomp function, we want to increment this count by 1. So let's just try this on the penguin, for example. We can do penguin dot stomp, and this will increment the stomp count, but it'll only increment the penguin's stomp count. Why? Because we used this new keyword called self. And self literally just refers to whatever object is currently calling the function. So if we had the penguin call stomp, then penguin is now self. That's all it is. So this is the same thing as saying penguin dot stomp count plus equal 1. These are exactly equivalent. It's just we use the self keyword here instead of using penguin to make things easier and reduce code accumulation. So let's talk about initializing new objects. So currently, this is our class, and right now when we initialize it, we have no parameters. But wouldn't it be kind of nice to, I don't know, specify the amount of feet without having to access a whole nother variable and have it on a separate line? Yes, it would. And if we want to do this, we can define a special function that each and every class has available. And this is called __init. And this is called any time that you make a new object. So whenever we call this, we're actually calling underscore underscore init. So whatever parameters you give to init, you will be able to take in as your constructor parameters. And this is also called a constructor because it makes a new object. And init obviously gets the self keyword to make sure you can set your variables for the object in question. And then we can take in any parameters we want. So let's just say feet in this case. Then we can just do self.feet because feet is a variable that we have for our animal. And this will be equal to the feet we put in as our parameter. So now you can see if we hover over this animal, it now has a parameter called feet, which means we can put in 2 for a penguin and we can put in 4 for a rhino and remove this line of code. So now if we were to, for example, print out both of the feet counts, penguin.feet and print out rhino.feet, and if we run this code, we will get 2 and 4 respectively, exactly as we did before. And now that we have these self variables, we can also just remove these other ones up here because they're no longer necessary. Because saying self.feet is equal to feet is going to set the exact same values, it's just you need to input them in here. And if you want to set defaults, you just set equals to, just like you would for a normal function. Just make sure they, line up properly. So let's say we start adding more parameters to our animal class, like we track its eyes and its main color. Wouldn't it be kind of cumbersome to go through each animal individually and type out how many eyes it has and its main color? Well, yes, when we have like 1,000 animals and they're all different. So the way we get around this is called inheritance. An inheritance is just like what it sounds like. Think about your family tree. You inherit certain traits from your parents. Same thing works with this. If we have the parent class of an animal, we can make a new class, and let's just call this our penguin, which can inherit all the properties from an animal and be its own thing. So this penguin will get every property of an animal. So if we were to, for example, let's just make a random variable. Let's just say any or an is equal to 2, just so it's a proper class. We can then create a penguin, and it'll have the exact same constructor as a normal animal. It inherits all of that. This will also have the stomp method, and it'll also have the stomp count. It is literally an exact clone of an animal. And since it is an exact clone of an animal, that means we can also initialize it just like it was one as well. So to do this, we will define our init function, and we will provide self. And in this case, we are going to take care of all of these parameters so we don't need to deal with them as a user. Then we can use the super keyword to talk about our parent. Super just means the animal that we're inheriting from. Super.init. Oh, sorry, not super.init. You just do super.init like this. Call super and then initialize. And then we can manually put in our feet, eyes, and our main color because they'll always be consistent. So we can do 2, 2, and black for our penguin. And now every penguin we make, we no longer need to specify. So if we have a penguin, no matter which one it is, it'll always be the exact same. That's what inheritance is lovely for. It'll keep things extremely consistent for you later down the line. And if you ever want to change your penguin class, you just go back up and say, oh, well, we have genetically growthed penguins to have 3 eyes. Now they all have 3 eyes. So even though inheritance is great, sometimes you don't want to use it for things that are just not related to each other. So for example, if we were to make a rhino, then we don't want to make a rhino inherit from a penguin because they're entirely different animals. But a rhino is an animal, so we can make it inherit from the parent animal class. So whenever you're going to make a new class, just say, is the child a parent? So for example, is a rhino a animal, or an animal in this case? If yes, and that makes sense, then good, make the class. But if we said, is a rhino a penguin? Well, no. So we probably would not make the rhino a child of a penguin. So in summary, classes can be used to better organize your code. These classes can then be made into objects which have their own unique properties. You can then use inheritance to make creating new objects easier and simpler. Simpler code leads to better code in the future and less confusion. And the best way to understand this is by making your own project. So what I challenge you to do is go take around 15 minutes and make your own type of zoo. Go see if you can make your own example using what I just taught you. And if you need some help, come right on back to the video. And with that, thank you for watching and follow for more tech tips.